Let's solve these problems. Find the greatest common factor or GCF. So let's start with 1, 24, and 32. So if the two or more numbers given are just small numbers, so we can just use the listing method. So I will apply listing method here. So I will list down all the factors of the given number. So let's start with 24. So the factors of 24 can be 1 and 24. Since 1 times 24 is 24. What else? We can also have 2 and 12, right? Because 2 times 12 is 24. What else? We can also have 3 and 8 because 3 times 8 is 24. Lastly, we can have 4 and 6. Since 4 times 6 it's 24. And then, also for the 32, let's list down its factors. So we can have 1 and 32. We can also have 2 and 16. What else? 4 and 8. So there's no more. And then from this list of factors, let's check all the common factors. So we can have 1, 2, 4, and 8 as the common factors. But since we're finding the greatest common factor, let's choose 8 as the GCF since it's the greatest common factor among 1, 2, 4, and 8. Okay? For number 2, we have 2,520 and 8,400. So this time, the given numbers are too big, right? So if you try to use the listing method, it will be a tedious task to list all their factors, right? So if that's the case, we can apply the prime factorization. So let's get first the prime factorization of the two numbers. So by the way, I already have a previous video about prime factorization. So if you haven't watched it yet, I will just link on the description the video tutorial so you can check it first. Because we will not be showing anymore the solution on how to find the prime factorization of these two numbers. So I will just use a calculator. So let's use this Casio FX991EX class Wiz to find the prime factorization of the two numbers. So for 2,520, let's input, press equal, and then shift fact. So here's the prime factorization. 2 cube times 3 square times 5 times 7. For 8,400, we will have 2 to the 4th times 3 times 5 times 7. Okay, the next step after we have the prime factorization of the given numbers, let's check for the common factors. So we have 2, we also have 3, we also have 5, and we also have 7. And then from these common factors, we need to put the least exponent. So the least exponent that we have is 3, right? Because 3 is less than 4. So let's put an exponent of 3 for the common factor of 2. Doing the same with common factor 3. So let's check what is the least exponent. So for this one, we have 2. And for this one, we have invisible exponent of 1. So the least exponent is 1, right? So let's put 1 as the exponent of 3. Likewise for 5, so they have both invisible exponent of 1. So the least exponent is the same as 1, right? Then for the 7 also, they have invisible exponents of 1. So we'll have 1 as the exponent of the common factor 7. And then to find the GCF, we just need to multiply all of these factors. So we have 2 cubed times 3 to the first times 5 to the first times 7. So 2 cubed it's the same as 2 times 2 times 2 or 8. So we will have 8 times 3 times 5 times 7. So using calculator, 8 times 3 times 5 times 7. So the GCF will be 840. For number 3, we have 600, 1,512, and 12,600. Again, let's use prime factorization. So we find the prime factorization of the three numbers first. So for 600, we have 2 cubed times 3 times 5 squared. For 1,512, we have 2 cubed times 3 cubed times 7. For 12,600, we have 2 cubed times 3 square times 5 square times 7. Okay, again, the next step is we need to find the common factors. So, we can have 2, we can have 3. This time, we cannot have 5, right? Why? Because although 5 is common in 600 and 12,600, 1,512 doesn't have a factor of 5. So, in finding GCF, take note of this, a factor is common only if it is common to all the given numbers, right? Likewise, for the 7, there's no common factor of 7 in 600. It's only in 1,512 and 12,600. So therefore, 7 is also not considered as a common factor of the 3. So therefore, we will list only 2 and 3 for the common factors. And then, let's check the exponent. So we will choose, again, the least exponent that appears for the common factor. So for 2, what is the least exponent? So all of them have exponent of 3, right? So there's no choice but to put exponent of 3 to the common factor 2. Next, for the common factor 3, let's check the exponent. So we have 3 to the first here, 3 cubed, and 3 squared. So the least exponent is 1, right? So therefore, we need to put 1 on the common factor 3 as its exponent. Then finally, the GCF is just the product of these two common factors, 2 cubed times 3 to the first. So again, 2 cubed, it's the same as 8. And then times 3 to the first, or 3. So 8 times 3, it's equal to 24. So therefore, the GCF is 24. Okay, so now it's your turn. So try to find the greatest common factor or GCF of 360 and 450 and just comment your answers.